Here we have our first of our memory makers for 7.1. This is middleman. You can see that if we are comparing or ordering percents, fractions, square roots, or scientific notation, the best way to do that is by changing them all to decimals because they're all equal. They all just are various forms of different numbers. But the easiest way to compare them is by making them all into decimals. Our second one actually shows us how we can change like decimals to percents, and that's Dr. Pepper. Decimals to percents goes 2 places to the right. Percents to decimals, you move the decimal 2 places to the left. Our third is scientific notation, where we talk about that if there is, no matter what's inside the road indicator for scientific notation, as you go to the outside, the answer, you're going to have no negatives. Now, that does not include if there is a symbol on the outside. That's only including what goes on inside of those absolute value markers. The fourth one has to do with scientific notation, and obviously I'm going to need to make this a little bit smaller so that you can see all of that. In order for it to be in proper format, you have to have only one digit before a decimal point in scientific notation. You can have as many numbers afterwards as you need, but you don't need anything that is just zeros. You need everything up until the point that the numbers are nothing but zeros, but that's how that works. Times 10 to an exponent. If that exponent is positive, that's going to make a very large value number. If the number is negative, that's actually a small value number, a decimal. It's not ever a negative number. And that's true for negative exponents all the time. Negative exponents do not make negative numbers. They just make small value decimal numbers. That brings us to our fourth one, which is a power of 10. 10 to the negative third, again, that's going to be a small value number. That negative makes it go into the denominator of a fraction. And that's going to get us, that tells you how many times 1/10 is going to be multiplied, which would get you 1 over 1,000 in this case, which would be equal to 0.001. Remember that we put the 1 below the decimal point and as many zeros as you have places, and that's how you can read a fraction or a decimal. At any point, you can stop this video in order to make sure that you have all of those written. The next of our memory makers is for 7.2. This is about sequences. We have 2 or so of memory makers for this as well. For this one, arithmetic means add. You're going to get a common difference for those. And that could be written as n plus 3 or n plus negative 3. Again, arithmetic starts with an A, and that's how we can remember that that means to add to get the next term. The other type of sequence is a geometric sequence. In a geometric sequence, we're going to multiply. That gives us a common ratio. That can be written as 3 times n or 1/3 times n. And in both of these cases, the first one means that the terms go up in value as you go left to right. For both of these, the second one would be if the terms go down in value or become less in value from left to right. Again, at any point, you can stop the video if you need more time. The next one is 7.3. This is where we go over order of operations and integer operations. So this is 7.3. In these, so far, you may not be able to use a calculator to do any of the calculations here on your SOL on Thursday. Sometimes they let a few slip through, sometimes they don't. So we're going to practice these in every way without a calculator as we have been all year long. Order of operations. The first thing with order of operations is that GEMDAS. GEMDAS tells us the order that we have to follow in terms of order of operations. Grouping symbols first, then exponents, then multiply and divide left to right, then add and subtract left to right. The next one as we go through is adding integers. Boy, if you can remember that song, it's really going to help. If you don't like the song, I'm not going to sing it to you, by the way. That's okay, but you need to remember that if you have the same signs in the problem, you add those two numbers and keep the sign of them because you have the same sign. If you have different signs, like one is positive and one is negative, you're going to subtract those two numbers and take the sign of the larger absolute value number as the sign of your answer. The next one would be if you're going to subtract. If you are subtracting integers, you have to KCC, keep, change, change. Then you have to add those two numbers. You have to follow these same rules that we talked about here. If you're subtracting, you KCC, keep the first number, change the operation to addition, then change the sign of the second number, and that's why you have to add. The last two are multiplying and dividing, and they actually both have the same symbol. I like to call this the X diva. Remember that she has her eyes closed and her mouth pursed. When you circle the signs of the two signs in the problem, the one sign that is uncircled will be the sign of the answer. Again, pause this if you need to finish copying. 7.4 and 7.6 are about proportions. This is the first one that I can, well, at least I hope that you can use a calculator for. This is where you have the percent proportion, similar figures, which is a little bit more difficult than percent proportions, and those kind of things. For these problems, like for the first one, you can look at that percent proportion. Percent over 100 equals part over the whole. That part could be anything like tip or tax or even a discount. When we talk about graphs, this could be the number of students who went to something over the total number of students, or the people who rode the bus over the total number of people who went on the field trip. So this is just one example, but there's a lot of things that this can work for. Remember that for tips and tax, you add tips and tax to get the entire amount, the total spent, the total bill, etc. For discount, you subtract. That's why it has a subtraction symbol. The I is turned sideways to remind you to subtract to get the sale price. The last thing is when you set up, like for similar figures, when you set up a proportion, you need to make sure that you have like labels up and down, and that they're also related across. The last part of this is remember that if you write down a proportion, but it's not given to you on your test in that form, it may be that you just need to turn your page. Remember that you can turn your page and show a variety of ways that that proportion could work by just turning the page. Does that make sense? Boy, I hope so. All right. Ask me any questions tomorrow if you're stuck. For 7.5, this is about surface area and volume of rectangles or rectangular prisms and cylinders. For surface area, that would be words that mean like to cover or to make, or the materials to make, that kind of thing. For volume, it's fill or hold. Now these are only two examples. There are more. You need to make sure that you are using the formula sheet. Make sure that you use that formula sheet. The last, almost next to the last, if you have a radius, that is equal to half of a diameter. That means you would multiply by a half, which is multiply by 0.5, or you would divide the diameter in two, like divided by 2 to get the radius. That would be used for those cylinders and the formulas there. Remember that scale factors, that's easy for volume. Whatever you multiply the side by is what you multiply the entire volume by. But unfortunately, for surface area, you've got to do the work for that one to make sure that that will happen. Please make sure that you are pausing at any time and going back and reviewing if necessary.